Let me ask you something that is going to sound absolutely crazy. Ready? Light does not move through space. Now hold on. Before you throw something at me, let me say it again. That beam of sunlight coming through the window right now, that flashlight you point at the wall, the light from a star that has been traveling for 1 billion years, none of it is moving through space in the way you think it is. And I know you are sitting there going, Feynman, I can see it move. I shine a flashlight. It goes from here to there. Obviously, it is moving. And you are wrong. You are beautifully, understandably, completely wrong. And by the end of this talk, you will understand why, and it will change the way you look at everything. Here is what I promise you. By the time we are done, you will understand what light actually does instead of moving. You will understand why the very idea of light traveling through space is a leftover from a wrong picture, a picture so wrong that the universe had to slap us in the face to fix it. And I think, honestly, the real story is much more wonderful than the fairy tale. So let us start where everyone starts. Let us start with what seems obvious. You are standing in a dark room. You have a flashlight. You click it on, boom. Light appears on the far wall. Now, it happened fast, faster than you could blink. But surely, the light left the flashlight, crossed the room, and hit the wall. It traveled. It moved. It went from A to B. That is what moving means, right? Something starts in one place and ends up in another place, and it takes some time to do it. And look, that picture is not entirely useless. It works for a lot of practical things. Engineers use it every day. You can calculate how long it takes light to get from the sun to the earth, about 8 minutes. You can bounce a laser off the moon and time the round trip. All of that works perfectly well if you treat light as a thing that moves from here to there. But here is where it gets interesting. Here is where it gets strange. Because when you start asking careful questions, really careful questions, that whole picture falls apart. Let me start with the first crack in the story. Back in the old days, people thought about waves. Sound is a wave, and sound needs something to wave in, right? Sound waves travel through air. Take away the air, no sound. Everybody knew this. So when people figured out that light is a wave, the natural question was, well, what is it waving in? What is the medium? Air? No, light goes through the vacuum of space. There is no air out there between the stars. So what is it waving in? And they came up with a beautiful answer. They said, there must be a substance filling all of space, an invisible, weightless, perfectly transparent substance, and light waves travel through it. They called it the luminiferous ether. Luminiferous. Light-bearing. What a wonderful word. And for decades, this was the accepted answer. Light moves through the ether the way sound moves through air. Now, the thing about the ether is that it had to have some very peculiar properties. It had to fill every corner of the universe. It had to be perfectly rigid, because light waves are transverse waves. They vibrate sideways, and only rigid materials support transverse waves. Try sending a transverse wave through water. It does not work so well. But the ether also had to let planets and stars pass right through it with no friction at all. So it is infinitely rigid and yet offers no resistance. Already a bit suspicious, no? But the real problem came when people tried to detect it. If the ether exists and the Earth is moving through it as it goes around the sun, then we ought to be able to measure our speed relative to the ether. Think of it this way. If you are in a car and there is wind blowing, you can tell the wind is there because sound takes longer to reach you from one direction than the other. Same idea. Light should take a tiny bit longer going one way through the ether than the other way, because the Earth is plowing through it. So in 1887, two fellows named Michelson and Morley built the most exquisitely sensitive experiment ever made up to that time. They split a beam of light in two, sent the halves in perpendicular directions, and then brought them back together to look for any tiny difference in travel time. They were looking for the aether wind, and they found nothing. Zero. Zilch. No difference. No matter which direction they pointed the apparatus, no matter what time of year, no matter what the speed of light was exactly the same in every direction. Now, think about how strange this is. Let me make sure you feel the strangeness. Suppose you are in a river. You are swimming upstream, then downstream. It takes you longer to swim upstream than downstream, obviously, because the current is pushing against you one way and helping you the other way. Even if you average the two, the average is not the same as swimming in still water. The current always slows you down on the round trip. Always. That is what the ether should have done to light. The Earth is moving through the ether, so the ether should act like a current. Light going upstream should take longer than light going downstream. The round trip should be slower in one direction. But it was not. It was exactly the same, every single time. People tried to explain this away. A physicist named Fitzgerald proposed that objects physically contract in the direction of motion through the aether. Lorentz developed the same idea mathematically. They said, look, maybe your measuring rod is shorter when it is pointing in the direction of motion, and that shortening exactly compensates for the time difference. It is a clever trick, but it is an ugly trick. You are saying the aether exists, but it conspires to make itself undetectable. Nature is not usually that sneaky. When a theory needs conspiracies to survive, that is usually a sign that the theory is wrong. Now, that is a devastating result. Devastating. It means there is no ether wind. It means you cannot detect any motion through the supposed medium of light. It means the whole idea that light travels through some substance filling space is wrong. Dead wrong. But let us not get ahead of ourselves. Let me tell you what came next, because it is one of the most beautiful pieces of thinking in the history of physics. A young man, about 26 years old, working in a patent office in Switzerland, decided to take this result seriously. Really seriously. Everybody else was trying to patch up the ether, trying to explain why the experiment gave a null result. Maybe objects contract when they move through the ether. Maybe clocks slow down. All sorts of clever fixes. But this young fellow, his name was Einstein, he said, what if there is no aether? What if the speed of light is just the same for everybody, no matter how they are moving? Now, that sounds simple. It sounds almost too simple. But think about what it means. You are standing still, and you measure the speed of a beam of light. It is going at, well, let us call it c, about 186,000 miles per second. Now I get in a rocket ship and fly past you at half the speed of light, and I measure the same beam. You would expect me to get a different number, right? Like if you were running toward a baseball that someone threw, the ball seems to be coming at you faster. That is just common sense. But no, I get the same number. Exactly c. The speed of light is the same for me as it is for you, no matter how fast I am going. That is not common sense. That is crazy. But it is what the experiments say, and so we have to take it seriously. Now here is where it gets truly wild. If the speed of light is the same for everybody, something else has to give. And what gives is our ideas about space and time themselves. Because speed is distance divided by time. If the speed comes out the same, but I am moving relative to you, then the distance and the time must be different for me than for you. Let me say that again. My rulers are different from your rulers. My clocks tick at a different rate than your clocks. Not because there is something wrong with my equipment, because space and time themselves are different for us. This is the special theory of relativity, and it is where our story about light really begins to get interesting. You see, in the old picture, there is space, which is like a big stage, and there is time, which ticks along separately. Things move around on the stage, and the clock ticks. Space and time are separate things, but Einstein showed us that this is wrong. Space and time are not separate. They are woven together into a single fabric called space-time. Now let me give you an analogy. Think about a map. On a map, you have north-south and east-west. Those are two separate directions. If you walk due north, you cover a lot of north-south distance and no east-west distance. If you walk northeast, you cover some of each. The total distance you walk is a combination of both. North, south, and east, west are not really separate things. They are just two components of your overall movement on the surface of the Earth. Space and time are like that. They are two components of movement through space-time. And here is the key idea, the really big one. Everything is always moving through space-time at the same total rate. Always. You, me, this table, the planet Jupiter, everything moves through space-time at the speed of light. Now wait, did I just say that? You are moving through space-time at the speed of light right now? Yes. But here is the thing. You can split that motion between space and time. If you are sitting still, not moving through space at all, then all of your motion through space-time is going into the time direction. You are aging. Your clocks are ticking. You are moving through time at the speed of light. Let me make sure you feel this. Right now, as you sit there, you are rocketing through the time direction at maximum speed. Every second, you move 1 second into the future. That sounds trivial, but it is not. That is what moving at sea through space-time looks like. When your space speed is 0, all your speed is in the time direction. Now think about a clock. What does a clock do? It ticks. Each tick marks 1 unit of movement through time. A clock that is sitting still relative to you ticks at the maximum rate. Every tick comes right on schedule. That is because all its space-time motion is going into time. But now, suppose you start moving through space. You get up and walk. Some of your space-time motion is now going into the space direction, and that means less of it is going into the time direction. Your clocks slow down, just a tiny bit, because you are walking slowly compared to light. But in principle, they slow down. The faster you move through space, the slower you move through time. This is not a minor detail. This is the whole game. Everything in special relativity follows from this one idea. Why do fast-moving clocks tick slowly? Because they are spending some of their space-time speed budget on moving through space, leaving less for time. Why do fast-moving objects get shorter? Same reason, from a different angle. Why can nothing with mass reach the speed of light? Because to go at sea through space, you would need to spend your entire budget on space, leaving 0 for time. And a massive object cannot stop moving through time. It always has some of its budget committed to the time direction. It is like a tax that mass imposes on you. You always owe some of your speed to time. And what happens when you get all the way up to the speed of light through space? Then all of your space-time motion is going into the space direction, and none of it is going into the time direction. Your clocks stop. Time stops. Now here is the punchline. Here is the thing about light that should make your hair stand up. For a photon, for a particle of light, time does not pass. Not time passes really slowly. Time does not pass at all. From the photon's perspective, if we could even talk about such a thing, the moment of its creation and the moment of its absorption happen at the same instant. There is no in-between. There is no journey. The photon does not experience crossing the room. It does not experience crossing the galaxy. For the photon, there is no distance between where it was emitted and where it was absorbed. Let me say that in a different way. You think the light from a distant star traveled for 1 billion years to reach your eye? And from your perspective, from the perspective of someone sitting here on Earth with clocks and rulers, yes, that is a perfectly valid description. It took 1 billion years by your clock. It crossed 1 billion light years of your space. But from the photon's own perspective, nothing. 0 time, 0 distance. The star and your eye are, in a sense, the same event for the photon. That is what I mean when I say light is not moving through space. It is not experiencing any journey at all. The whole idea of traveling implies duration, implies distance along the way, implies a sequence of events between departure and arrival. And for light, none of that exists. Now let me do the Feynman check. Let me say this as if I am talking to a bright 12-year-old. Imagine everything in the universe has a speed budget. The budget is always the same amount, the speed of light. You can spend this budget on moving through space or on moving through time, but the total is always the same. If you sit perfectly still, your whole budget goes to time and your clocks tick as fast as possible. If you start running, Some budget goes to space, and your clocks slow down a little. Light spends its entire budget on moving through space. It has nothing left for time. So for light, no time passes. It does not travel. It simply connects two events, the way a line connects two dots on a piece of paper. The line does not move from one dot to the other. It just is. Now, I know what some of you are thinking. You are thinking, Feynman, this is just wordplay. You are just describing the same thing in a fancy way. But it is not wordplay. It changes real, physical, measurable things. Let me give you a concrete example that shows how this is not just talk. Let us think about muons. A muon is a particle, a heavier cousin of the electron. Muons are created when cosmic rays hit the upper atmosphere, about 10 miles up. Now, a muon has a very short lifetime. It lives for about 2/millionths of a second, and then it decays. 2/millionths of a second. Even moving at nearly the speed of light, in 2/millionths of a second, a muon can only travel about 2,000 feet before it dies. But the atmosphere is 10 miles thick. So these muons should never reach the ground. They should all decay, long before they get here. But they do reach the ground. We detect them, lots of them. How? From our perspective, the answer is time dilation. The muons are moving so fast, nearly the speed of light, that their clocks are running slow. Their 2/millionth of a second lifetime is stretched out, from our point of view, to be long enough for them to cross the whole atmosphere. But here is the beautiful part. From the muon's perspective, its clock is running perfectly normally. It still lives for 2/millionths of a second by its own clock. So how does it reach the ground? Because from the muon's perspective, the atmosphere is length contracted. The 10 miles of atmosphere has been squished down to a few hundred feet. The muon does not need extra time. It does not need to travel far. The distance has been compressed. Both descriptions are correct. Both are real. There is no contradiction between them. The muon reaches the ground because space-time is flexible. And this flexibility, this interplay between time and space, is the same principle that makes light zero interval. The muon is moving at 99.9% of c, and already time and space are warping dramatically for it. Now imagine going the last tiny fraction. Imagine reaching c itself. At that point, the time dilation is infinite, and the length contraction is total. No time passes, and no distance exists. That is the photon's world. Here is one. Suppose I have two clocks, identical clocks. I keep one here, and I put the other one on a fast airplane. The airplane flies around the world and comes back. When I compare the clocks, the one on the airplane is behind. It has ticked fewer times. Less time has passed for it. This is not science fiction. This experiment has been done many times. With atomic clocks on airplanes, on satellites. The GPS system in your car works only because the engineers account for the fact that the clocks on the satellites tick at a different rate than clocks on the ground. If they did not correct for this, the GPS would be off by miles. So time dilation is real. It is not philosophy. It is engineering. And it tells us something profound about the nature of light. Here is a tricky misconception I want to destroy. People sometimes say light slows down when it goes through glass or water. You have probably heard this. The speed of light in water is about 3/4 of c. The speed of light in glass is about 2/3 of c. So light slows down, right? Wrong. The photons themselves are always going at c. Always. What happens in glass or water is more subtle and more interesting. The photons interact with the atoms in the material. A photon gets absorbed by an atom. The atom gets excited, and then it emits a new photon. There is a tiny delay in this process. So the light appears to move slower because of all these absorption and re-emission events. But between the atoms, in the gaps, the photons are always going at c. The slowing down is an illusion caused by the zigzag path and the absorption delays. The photon itself is never anything other than light speed. Why does this matter? Because it reinforces the point. You cannot slow light down. You cannot speed it up. Light is always at c. And a thing that always goes at sea is a very different kind of thing than a baseball or a bullet or a sound wave. A baseball can go fast or slow. A sound wave can go fast or slow, depending on the medium. But light is always sea, and that absoluteness, that stubbornness, is a clue that light is not moving through space in the ordinary sense. Let me try another angle on this. Let me give you a thought experiment. Imagine you are a photon. You have just been emitted by an atom on the surface of a star. In the old picture, you would now begin a long, lonely journey across the void. You would cross millions of miles of empty space, maybe for years, maybe for centuries, until you finally bump into something, an eyeball, a leaf, a detector. But you are a photon. You do not experience time. You do not experience distance. The moment of your creation and the moment of your absorption are the same moment for you. From your perspective, there is no void. There is no journey. There is only this. You connected two events: an atom on a star surface and a molecule in someone's retina. That is all you did. You did not cross anything. You did not move through anything. You connected. Now, is this just a quirky way of looking at it? No. This is what the mathematics of relativity actually says. The proper time along a light ray is 0. The space-time interval along a light ray is 0. These are not approximations. They are exact results. Let me explain what proper time means. Proper time is the time measured by a clock traveling along a particular path through space-time. For you, sitting in your chair, your proper time is what your wristwatch reads. For an astronaut flying at high speed, proper time is what the clock on the spaceship reads. And for a photon, the proper time is 0. A clock riding along with the photon would read 0 elapsed time between emission and absorption, no matter how far apart those events look to you and me. Think about that. If I asked you, how long did it take the light from the sun to reach us? You would say 8 minutes, and you would be right by our clocks. But the light's own clock says 0. There is no contradiction. Both are correct. The disagreement is not a problem. It is the point. Time is not absolute. It depends on who is measuring. Now I want to take this further. Let me talk about something called a space-time diagram. I am going to try to do this without too much math, but I want you to see the geometry of it. Imagine a piece of paper. The horizontal direction is space, say left and right. The vertical direction is time, going up. Every point on this paper is an event, a specific place at a specific time. Your life is a line going upward on this paper because you exist at each moment of time in some place. That line is called your world line. Now, if you are sitting still, your world line goes straight up. You stay in the same place and time passes. If you start moving to the right, your world line tilts. The faster you move, the more it tilts toward the horizontal. Here is the key. Light moves at the maximum possible speed. On this diagram, a light ray always makes a 45-degree angle. Always. That is the speed limit of the universe drawn as a geometric fact. Nothing can tilt more than 45 degrees. Now look at a light ray's world line. It goes at 45 degrees. And here is the remarkable thing. In the geometry of spacetime, which is not ordinary Euclidean geometry, a 45-degree line has 0 length. 0 space-time interval. That is what I mean when I say the photon does not experience any journey. Its world line has 0 interval. It is, in the space-time sense, a single point stretched out, or, if you like, it is a connection between two events that has no extent of its own. This is so different from our everyday intuition. In everyday life, a line between 2 points has length. You walk from your house to the store, the path has distance. But in space-time, the path of light has 0 interval, not small, 0. Let me give you another analogy. Think about the shadow cast by a tall pole when the sun is at different angles. The shadow can be long or short depending on the angle, but the pole itself does not change. The shadow is just a projection of the real object into a lower dimension. Similarly, what we see as light moving through space for 8 minutes is just our projection of a deeper reality. In the full space-time picture, the light ray has 0 interval. The motion and duration are just how it appears when we slice space-time into separate space and separate time with our particular clocks and rulers. Now let me bring up something that I think is not discussed enough. People hear nothing can go faster than light, and they imagine light as the fastest car on the highway. Like it is really moving. It is just moving the most. But that is the wrong picture. Light is not the fastest possible thing. Light is the thing that does not move through time at all. Massive things, like you and me, always move through time. We are stuck partly in the time direction. We can never get out of it entirely. We can get closer and closer to light speed, but we can never reach it because we have mass, and having mass means you're always moving through time, at least a little bit. Light has no mass. It has no obligation to move through time. And because it does not move through time, it goes at c through space. That is not because c is really fast. It is because c is what happens when you put all your space-time motion budget into the space direction and leave nothing for time. The speed of light is not a speed limit in the way that a speed limit on the highway is a speed limit. It is a structural feature of space-time itself. And this connects to something else that people often get wrong. People say light has no mass, and then they say, but wait, E equals mc squared, and light has energy, so does it have mass? No. The full equation, the real equation that Einstein wrote, is E squared equals P squared C squared plus M squared C to the fourth. That is the complete equation. E equals mc squared is the special case for things at rest. Light is never at rest. A photon has energy and momentum, yes, but it has zero rest mass. And that zero mass is what allows it to go at c. That is what frees it from the tax of time. Let me put it another way. Mass is what anchors you to the time direction. Mass is the reason you cannot escape time. The more massive you are, the harder it is to get close to the speed of light, because you need more and more energy. Your time tax is heavier. A proton needs a tremendous amount of energy to get to 99% of c. An electron, being lighter, needs less. But a photon, having zero mass, needs no energy to be at c. It is automatically at c. It has never been anything else. A photon is born at c and dies at c. It does not accelerate from zero. It does not speed up. It simply exists at c, because that is what zero mass means in the geometry of space-time. And this is why I say light is not moving through space. In the ordinary sense of moving, something occupies one position, then later occupies a different position, and the later is the crucial word. Light has no later. Its departure and arrival from its own perspective are simultaneous. The concept of moving requires the passage of time, and light does not experience time. I want to try one more thought experiment. This one I find very beautiful. Suppose a friend of yours is on a spaceship going very, very fast, almost the speed of light. You watch the spaceship from Earth. What do you see? You see the spaceship moving quickly. You also notice something strange. Your friend seems to be moving in slow motion. Everything inside the ship seems sluggish. Your friend is aging more slowly than you are. Their clocks are ticking slower. This is real. It is not an illusion. Now, speed up the ship a bit more. Even more time dilation. Your friend barely seems to be moving through time at all. Now, push them all the way to the speed of light. Suddenly, your friend's time stops entirely. From your perspective, they are frozen in time. But from your friend's perspective, everything seems normal inside the ship. It is the outside universe that has gone strange. The distances between things have contracted to nothing. The entire universe, in the direction of travel, has squished down to zero thickness. The destination is right here. The journey takes no time and covers no distance. Now, your friend cannot actually reach the speed of light because they have mass. But a photon is born there. A photon exists in that state. For a photon, the universe is a flat sheet with no thickness in the direction of travel. There is no space to cross. There is no time to elapse. You see why I say the old picture is wrong? The old picture says light is a little projectile that shoots from here to there, crossing space, taking time. The real picture says light exists in a mode where space and time, as we know them, do not apply. The crossing and the taking time are artifacts of our perspective. They are real for us, yes, but they are not properties of the light itself. Now, I need to be careful here. Some of you might be thinking, well, can we actually talk about the photon's perspective? And that is a good question. Technically, you cannot set up a valid reference frame moving at the speed of light. The mathematics breaks down. You get 0 divided by 0. So when I say from the photon's perspective, I am taking a limit, I am saying, let us look at what happens as we go faster and faster, approaching C, and see what the trend tells us. And the trend is clear. Time dilation goes to infinity. Length contraction goes to 0. Proper time goes to 0. These are mathematically rigorous statements. And they tell us that whatever is happening with the photon, it is not traveling in any meaningful sense. Let me now connect this to something deeper. Why does any of this matter? Why should you care? Because it changes what you think reality is. Most people walk around with a picture of the universe that is basically Newtonian. There is space, a big empty box. There is time, ticking along uniformly. Things move around inside the box, and the clock ticks. Light is one of those things. It moves really fast, but it moves. The truth is far more interesting. Space and time are not separate. They are one thing, space-time, and different observers slice space-time differently, the way different people might slice a loaf of bread at different angles. Each slice looks different, but the loaf is the same. And light does not slice the loaf at all. Light is like the edge of the loaf. It is a boundary. It is the limit. It is where space and time trade off completely. On one side, you have things with mass, plodding along through time, able to move through space but never escaping time entirely. On the other side, you have light moving entirely through space, experiencing no time at all. And this boundary, this edge, is not just some curiosity. It determines the structure of the entire universe. It determines what you can see and what you cannot. It determines causality, which events can influence which other events. Your light cone, the spreading sphere of all possible light rays from any event, divides all of space-time into the accessible and the inaccessible, the past and the future, and the unreachable. Let me say something about that, about causality, because people do not appreciate how profound this is. Right now, as you sit there are events happening in the universe that you can never know about. Not because the information has not reached you yet, but because it cannot ever. There are places in the universe so far away, and the universe is expanding so fast that light from those places will never, ever reach you. The space between you and them is growing faster than light can cross it. Now, that sounds like light is losing a race. But remember what we said. Light does not race. Light connects events with zero interval. The issue is not that light is too slow. The issue is that the geometry of space-time itself has changed. New space is being created between you and those distant galaxies, and the creation of space is not bound by the speed of light. Nothing is moving faster than light. Space itself is stretching, and in that stretching, some events are permanently cut off from your light cone. You will never see them, they will never see you. Not in 1 billion years. Not in 1 trillion. Never. That is the universe we live in. A universe where what you can know and what you cannot know is determined by this thing, this boundary, this zero interval connection we call light. And light itself, the arbiter of causality, the determinant of what is real and accessible, does not experience any of it. There is something deeply beautiful about that. The thing that connects events in the universe, the thing that carries information, the thing that lets you see the stars, does not itself experience any of it. Light is the messenger that has no experience of the journey. It is the connection between moments that itself exists outside of moments. I sometimes think of it this way. We are trapped inside time. We cannot stop our clocks. We age, we change, we move forward through the seconds, and there is nothing we can do about it. But light is free. Light has escaped time entirely, And yet, paradoxically, light is the thing that makes our experience of time possible. You only see things because light arrives. You only know the past exists because light from it has reached you. Light enables our experience of time while being entirely outside of time itself. Now, is this philosophy or is this physics? It is physics. Every word of it corresponds to a precise mathematical fact in the theory of relativity. The proper time is zero. The space-time interval is zero. The Lorentz factor goes to infinity. These are not metaphors. These are calculations. And I have not even talked about gravity yet. Let me take just a moment on this, because it makes the story even stranger. In general relativity, Einstein showed that mass and energy curve space-time. The sun, for example, creates a dip in the fabric of space-time around it, and light follows the contours of that curved space-time. When light passes near the sun, it bends, not because some force is pulling on it. Light has no mass for gravity to grab in the Newtonian sense. It bends because space-time itself is curved, and light follows the straightest possible path through curved space-time. That path, which we call a geodesic, just happens to be curved when space-time is curved. Now, here is the beautiful thing. Even in curved space-time, the light ray's proper time is still zero. The space-time interval along the light ray is still zero. No matter how much the light bends, no matter how wildly space-time is curved, the photon still experiences no time. It is still a zero interval connection. Think about light leaving a star near a black hole. The space-time is so warped that the light curves dramatically. From our perspective, the light takes a long, winding path. It might even orbit the black hole several times before escaping. But from the photon's perspective, still zero time, still zero interval. The long, winding path is an artifact of how we project the four-dimensional reality onto our three-dimensional picture. The photon does not care about the curves. It does not experience them. Even more remarkable is what happens at the event horizon of a black hole. Light that reaches the event horizon cannot escape. From the outside, it looks like the light slows down and freezes at the horizon. But the light is not slowing down. It is still going at sea locally. What has happened is that space-time itself has curved so severely that all forward-pointing directions lead further into the black hole. The light is still following a zero-interval path. It is still not moving through space in the sense we have been discussing. It is just that the geometry of space-time has closed around it like a trap. So the story of light not moving through space is robust. It holds in flat space-time. It holds in curved space-time. It holds near black holes. It holds everywhere because it is not a trick of perspective. It is a fundamental feature of what light is. But let me tell you something I think is important. The math alone does not give you understanding. Understanding comes when you sit with these ideas and turn them over in your mind and feel the strangeness of them. I can write down the equations for you in 5 seconds. But the equations do not tell you what it feels like to realize that the sunlight on your face did not, from its own perspective, travel at all. You have to sit with that. You have to let it be weird. And then, slowly, it becomes not just weird, but wonderful. Let me push this one more step. I hinted earlier that I would come back to this, and now I want to pay it off. If light does not experience time or space, what is it doing? What is actually happening when a photon goes from the sun to your eye? In the framework of quantum electrodynamics, which is the most precise theory of light and matter we have, a photon is not really a little ball flying from A to B. It is an excitation of the electromagnetic field. The electromagnetic field exists everywhere in space-time. When an electron in the sun changes its energy state, it creates a disturbance in this field. That disturbance propagates according to the rules of the field, and when it reaches an electron in your retina, it causes another energy change. It is absorbed. But what do we mean by propagates? In the quantum picture, the photon does not take a single path from A to B. It takes every possible path, including crazy ones that loop around the galaxy and come back. This is the path integral form. You add up all the possible paths with their associated phases, and most of them cancel out. The paths that survive the cancellation are the ones that look approximately like a straight line from A to B. This is why light seems to travel in straight lines. But it does not, fundamentally. The photon explores all of space-time simultaneously. Let me explain this more carefully, because it is one of the most astonishing things in all of physics. In quantum electrodynamics, to calculate the probability that light gets from A to B, you have to imagine an arrow for each possible path, a little arrow, like a clock hand. For each path, the arrow points in a particular direction, and that direction depends on how long the path is. Now you add up all the arrows, head to tail, like adding vectors. For paths that are near the straight line from A to B, the arrows all point in roughly the same direction. They add up. They reinforce each other. But for paths that are crazy, paths that go off to the side, or loop around, or zigzag wildly, the arrows point in random directions. They cancel each other out. So the net contribution comes almost entirely from the paths near the straight line. And that is why light appears to go in a straight line. But it is crucial that you understand this. The straight line is not what the photon actually does. The straight line is what you get after you add up all the paths. Every single crazy path contributes a little bit. It is the sum of all of them that gives you the behavior we observe. The photon does not choose one path. It does all of them. This is why light can do surprising things. Diffraction, for example. When light goes through a narrow slit, it bends, it spreads out. In the old picture of light as a thing that moves in straight lines, this makes no sense. Why would light bend? But in the path integral picture, it is perfectly natural. The slit blocks some of the paths. Without those paths, the cancellation does not happen as completely, and the remaining paths add up differently. The light spreads, it bends, it goes where a straight line traveler would not go. This is deep. This means that even the path of light is not really a path. It is a statistical result, an average over all possible paths, weighted by quantum phases. The concept of a trajectory, the idea that the photon was here and then there and then over there, does not apply. Between emission and absorption, the photon does not have a trajectory, it does not have a position, it has a probability cloud that extends over all of space. And if you want to test this, you can. There is an experiment, the most famous experiment in quantum mechanics, the double slit experiment. You send photons, one at a time, toward a barrier with two narrow slits. Behind the barrier is a screen. Each photon hits the screen at one spot, one tiny dot. But after thousands of photons, the dots form a pattern, not two strips, one behind each slit, which is what you would expect if each photon went through one slit or the other. No, you get an interference pattern, light bands and dark bands, exactly the pattern you would get if each photon went through both slits simultaneously and interfered with itself. Think about that. A single photon hitting the screen at one point somehow knows about both slits. It behaves as if it explored both paths. And if you try to catch it, if you put a detector at the slits to see which one the photon went through, the interference pattern vanishes. The act of observing destroys the multipath behavior. The photon only picks a single path if you force it to by looking. This tells us something very deep about what light is. Between creation and detection, a photon is not a little bullet following a line through space. It is something more abstract, more spread out, something that encompasses all possible paths. The movement through space is something that only crystallizes at the moment of detection. Before that, it is not meaningful to ask where the photon is. So when you put all this together, the relativity story and the quantum story, you are left with a picture of light that is radically different from the common one. A thing that explores all paths simultaneously is not moving from A to B, it is connecting A to B through the entire structure of space-time. The question, where is the photon right now, is not a question with a definite answer between emission and absorption. The photon does not have a definite position in between. It is a connection, not a traveler. So when I say light is not moving through space, I mean it at multiple levels. At the relativity level, Light experiences zero proper time and zero proper distance. It does not traverse anything from its own perspective. At the quantum level, light does not take a single path through space. It takes all paths. There is no definite trajectory to call movement. The very concept of moving through space comes from our everyday experience with baseballs and cars and people walking. Those things have definite positions at each moment of time. They follow definite paths. But light is not like a baseball. It does not have a position between emission and absorption. It does not follow a definite path. And it does not experience any time elapsing during the process. I realize this is a lot to absorb. So let me bring it back down to earth. The next time you see a sunset, I want you to think about this. The light from the sun, it left the surface 8 minutes ago by your clock. It crossed 93 million miles by your ruler. It passed through the atmosphere, scattered off nitrogen and oxygen, which is why the sky is blue and the sunset is red. All of that is true from your perspective. But the light itself, it did none of that. For the light, the surface of the sun and your eyeball are the same event. No distance, no duration, no journey. The entire crossing, the 93 million miles and the 8 minutes, is a projection, a shadow of a deeper reality where the light simply connects the sun to your eye with zero interval. You are seeing the sun not because light traveled to you, but because space-time has a structure that allows zero-interval connections between events. And those zero-interval connections are what we call light. That is what light is. It is not a thing moving through space. It is the structure of space-time itself, connecting events across what we experience as distance and time, but what is, in the deepest sense, no distance and no time at all. And I think that is extraordinary. I think that is one of the most beautiful things we have ever figured out about the world. That the thing we see, the thing that makes vision possible, the thing that fills the universe with information, is not a traveler. It is a connector. It does not move. It links. That is what I wanted to tell you today, and I hope it makes you look at the light a little differently from now on. Now, I want you to think about this. I have given you two ways of seeing why light does not move in the usual sense. One from relativity, one from quantum mechanics. Which one bothers you more? Which one keeps you up at night? I would be fascinated to know what people find most unsettling about this. So tell me, write it down somewhere, share it with a friend. Which part of the story of light breaks your picture of reality the most?